Everybody get up, it's time to slam now. We got the real jam going down. Welcome to the Space Jam. Here's your chance, do your dance at the
The evil empire must be defeated, and the only way for the Old Republic to win is if a device is created that can remove the Empire's TIE fighters from the home sector, place torpedoes in all 4 of the Death Star's rotating quadrants, raise the Millennium Golf Ball, and recall the fleet back to the home sector. Ultimately, a device is needed that can score the most amount of points by completing these tasks in only 40 seconds, and must also be reliable in sequential battles against the Empire. We had to use design tools to analyze the requirements needed in the device, including a house of quality, function tree, specification chart, and a morphological chart. On the house of quality, some key customer requirements are: no damage to the arena, the device must run autonomously, be easy to set up and reassemble, and it also must fit in a go, no-go box. Continuing on to the engineering requirements, the 2 that ranked the highest on relative importance are dropping torpedoes into the Death Star every 1/4 rotation, and moving the fleet at least 2 inches toward the home sector to get them over the sector dividing line. Another important engineering requirement is material durability. The device must be able to withstand many runs, both in testing and competition, without fatiguing or malfunctioning.
The function tree expands the main function of defeating Darth Uga into 4 main subfunctions. The 2 most important subfunctions as determined by the House of Quality are dropping torpedoes into each quadrant of the Death Star and returning the fleet to the base sector. Dropping the torpedoes includes successfully timing the Death Star's quadrants and escaping from the blast zone after successfully attacking. Returning the fleet entails isolating a boundary while keeping them in the base sector. These functions need to be performed while adhering to operations specifications. The specification sheet gives numeric values to the engineering requirements while specifying restrictions on how they are to be met. The specifications for each requirement were primarily determined from the competition requirements, while others were obtained from a combination of theoretical analysis of needs and research of devices which perform similar subfunctions. An example of this is the kinematic specifications, which results solely from theoretical analysis based on the competition requirements. Specifications for some requirements also place restrictions on viable solutions for other requirements. One such case is energy sources, which are limited to devices provided in the mechatronics kit, and this is critical to meeting the force and kinematic specifications. One of the more important engineering requirements is kinematics, for which the device must be able to move at least 2 feet along the plane of the battle zone, extend at least 21 inches above the floor, and be able to rotate at least 180 degrees. Ultimately, all specifications must be met in order to create a successful solution.
At this stage, we've also begun preliminary ideation for each function and subfunction of the device as shown in the morph chart. To banish the TIE fighters from our section on the track, our ideas include using linear bearings, a sweeping arm, rolling linked arms, and scissor arms. Also, to minimize the coefficient of friction, we discussed using a cow mover, applying lubricants to the track, and putting additional material under the TIE fighter. Although we realized that using lubricants would damage the track and therefore disqualify our team, we put it on the chart as part of the ideation exercise.
The initial step to the creation of our device is to finalize and implement team planning tools to help us fully analyze the work process that will lead to successful project management. The planning tools we plan to use throughout the span of the competition are a planning tree, team Gantt chart, job responsibility matrix, and a priority matrix. The planning tree allows us to manage and generalize tasks into an overarching topic. These generalized topics most importantly include problem definition and understanding, conceptual design, and implementing a finalized design for the final competition. Subsequently, using the prioritization matrix, we're able to quantify the relative importance of certain tasks from the planning tree. Tasks such as safety and design analysis, as well as construction of the device, hold the greatest emphasis on our team priority. From the planning tree and prioritization matrix, project scheduling is materialized in the form of the team Gantt chart. As seen on the following chart, past deliverables marked in red and current status in green denote progress of the design competition thus far. As for future endeavors, we plan to collaborate on concepts for the first team competition of raising the Millennium Golf Ball, This Gantt chart serves as an excellent tool for feedback and project scheduling progress. Adjacent to our project scheduling, it is also important to delegate roles amongst the team, and this can be done efficiently through the accompanied responsibility matrix.
Our plan going forward is to adhere to our project management tools and continue generating and testing concept designs. Additionally, our goal is to build a successful device to defeat the evil empire.
Y'all ready for this?